Cool. Thanks for having me. I'm Maria Höltö from the V8 team at Google. I'm going to talk about explicit compile hints, which is a feature we are developing in V8, and we'd like to propose it to WebPerf. So compile hints are hints inserted into the JS code about which function should be lazy and which should be eager. I'll tell you in a minute what that means. This is part of our real-world performance story. We have been working on real-world web performance for like a decade now. And like pretty early, we realized that parse and compile times are significant for real-world web performance, especially for the code load, which means we don't have stuff in the cache. This is like not normally captured in benchmarks all that much, because benchmarks normally load a page and then they do like zillion operations and then they measure that time. So it's hard to capture parse and compile, but for real world, it's very important. So lazy and eager compilation is something that all browsers implement. It's a very important optimization for the web, because many web pages contain a lot of code that is not used, especially not on startup. Like maybe some of the code is used if a user does like a specific interaction, or maybe it's completely unused. So by default, all web browsers say JavaScript functions are lazy. That means we do the minimal work until the function is actually called. So when we compile the script, when we see it the first time, we only pre-parse. That is to do the minimal work to find the function end. In JavaScript, it's unfortunately hard. We can't like count parents or something because the syntax is so complicated that we actually need to like actually parse to know where the function ends. But we try to do the minimal work there. And in V8, this is done on a background thread during the network load. And then when the function is actually called, then we need to do the work. So then we need to parse and compile and execute. And all that has to happen on a foreground thread, because the foreground thread is waiting for the function to execute, so we don't have a choice. Well, for eager functions, we do the opposite. So we do the work up front. So when compiling the script, we already parse and compile. Again, this happens on the background thread in V8 and during network load. And then when we call the function, then we only need to execute it. That still has to be in the foreground thread. There is no like background thread JavaScript execution. By the way, interrupt me if something is not clear. I have this huge sort of background information about JavaScript. I'm coming from the sort of JavaScript engine side. Cool. Bas?
A quick question. I assume that this means that when you execute, you potentially block on the background thread to finish the compilation in case it hasn't yet, because the network load happens to be fast.
So we only, like when you mean the in the eager function case where the background thread is parsing and compiling. Yes. We do that when we sort of see this whole script. We kind of do that, and only after that is done, then the script is ready. So
okay, so the execution is just not triggered. The execution of the whole script is not triggered.
Yeah, exactly, because we do the work up front. So the sort of the execution of the whole script is only like the execution of the top level only starts after.
What if it's a parser? What if it's a parser blocking script? Does that mean that the entire parser, the entire HTML parser, is blocked until the background thread is done?
Yeah, basically, but like this is why the default is lazy. So the default is we want to do like the minimal amount of work on that thread. Yeah. And the eager one is then the sort of optimization. Like sometimes some browsers think some stuff is eager, but the default is lazy. And eager compilation matters. So I did this experiment where I loaded the web page. I recorded which functions were actually called, even though they were lazy. And then I did another run where I loaded the page again, but this time I compiled those functions eagerly. And then I measured like parse and compile times, foreground and background. I did this with 20 most popular web pages. There is a doc. The slides are linked in the agenda, and there is a link here to the doc where you can read more about this experiment. And the results were that almost all pages improved. The parse and compile times improved with this optimization, and the average improvement was pretty big, like 630 milliseconds of foreground time. Of course, we add some time to the background, but it's very good in proportion to like how much foreground time we save. So most of the pages improved. 2 pages of this set we're using dynamically generated content, where basically the server generates a JavaScript and then serves that. And with this kind of content, there is like nothing we can cache, because the next time we load the page, the server sends like another JavaScript file, and we cannot like recognize which are the corresponding functions now. So this experiment won't work for those pages, but actually compile hints might still work because we can also insert compile hints to the dynamically generated content. So for those pages, this experiment is a bit pessimistic. And then, so this was 19 pages. There was also one page where this didn't improve. That was Wikipedia front page, which doesn't have all that much JavaScript, but I included it for completeness because it was one of the popular web pages. We also did some experiments with actual web pages at Google. So for this, we used the version of compile hints where you mark the whole file for eager compilation. And Google Docs have like userland load metrics where they measure the wall clock time of certain sort of page loaded milestones on their sort of userland. And they report like 3 to 5% improvements in their metrics when they selected their core file for eager compilation. You can also already control lazy versus eager compilation in Chrome and Firefox. In Safari, this doesn't work, but in Chromium and Firefox, we implement the PIFI heuristic. So you might have heard about IFIs, which is immediately invoked function expressions, where you have the parent, then you have the function body, then you have a closing parent, and then the call. So this is like immediately invoked. But we need to do the parsing decision, lazy versus eager, already before we see the function body and before we start parsing that. So we call this PIFIs. It's potentially invoked function expression, where we have seen the opening parent, but we don't yet know if this is actually invoked or not. And the heuristic is that in Chromium and Firefox, these functions are eagerly parsed. In Safari, they don't follow this heuristic. But this is pretty well known for web developers, and this has been used in production. At least Facebook has experimented with this. There is a library called optimize.js that tries to figure out which functions to wrap in parents and so on. So this definitely has been used. But this is not great. We can't add parents everywhere, especially for modern JavaScript, like methods and like setters and getters can't really wrap those in parents. And that also forces using function expressions instead of function declarations. So if you want to not call that function, but have the parent, then you need to assign, like let a equals, then that function. And during runtime, we need to do the assignment to this variable, and there is a small cost associated to that. And really, just using this for forcing eager compilation is a hack. This is not advisable. So a legit question at this point is like, why don't you just cache better? And indeed, all browsers implement code cache, where they cache compiled JavaScript code. And some of the benefits you can get from compile hints you can also get by caching, but not everything. So in particular, you have code loads where you don't have the stuff in the cache. It's a bit hard to count like how many scripts loads are called, because it really depends like what kind of script loads do you even count in this measurement. But something like 15% of script loads that we would potentially cache, we don't have it in the cache. So it's a pretty significant amount. And some web pages update very frequently, like they update maybe several times a week or even daily. So that forces basically like once a day, every user gets the code script. And some web pages use uncacheable code patterns where they dynamically generate the code, like during each page load, so we can't really cache. Also, caching inline scripts is hard. So if you have a script embedded in your HTML and then the HTML changes, the question is, did the inline script now change or not? It's hard to figure out. It's also hard to find an optimal point for creating the cache. So there we either generate the cache very early, it's smaller, but it's not as comprehensive, or we generate the cache later, it's more comprehensive, but it's also bigger and slower to process. So it's hard to find the optimal time. And one interesting thing that we found when we were working with Google web developers was that Google Docs told us that the significant proportion of their page load are like opened, like somebody opening Google Docs on a background tab. And this might be a different code path than opening it on a foreground tab. So if we do the background load and we generate the cache, it might not be representative for the foreground use case. And it's hard for us to figure out like what to cache in this kind of case. So we also worked a lot minimizing the cost. When we get the eager and lazy compilation wrong, there is a blog post link where you can read what we did. We also improved caching. In particular, we now generate compile hints and put those compile hints into the cache. So we have them available when we have the cache. But we couldn't quite get the same benefits that we would get with explicit compile hints. So at this point of the work, we conclude that we would like to have this explicit signal from the developers, which functions should be eager and which should be lazy. So this proposal is to first add this whole file compilation hint. It's called all functions called on load currently. So this means all functions in this file are probably needed on page load, so they should be compiled eagerly. And in the future, we want to add a version where you can mark individual functions for eager compilation. So for this, you would have like a different function called on load tag, and then the data in some format that we need to still design. But first, we want to go with the whole file version. This is also something our users want because they mostly have like a core file, and they want to mark that core file for eager compilation. So it's like basically user ergonomics. We also considered alternatives, like using some kind of a directive, like use eager, like there is use strict. This could be at the top level or before a function, but at least in the per function use case, this is not really feasible because it bloats the source code too much. Like you might think that it doesn't really matter for like network load because it's compressed, but actually we need to still parse it and like process the directive, so it's just too much. And we also considered putting the data in an HTTP header or in the script tag, but there the feedback was that this gets out of sync with the source code easier. So users want it to be in the source code so that the tools that process the source code also process it, and it is less likely to get out of sync. So for web developers, we imagine that this could work with PGO. So they would use profile guided optimization to figure out which functions are needed on the page load and select those functions for eager compilation. So for the file-based version, they could either construct a core file from those functions they know are important and mark that for eager compilation, or if they already have such a core file, then just mark that. And in the future, we want them to use this PGO data and like input that directly as per function compile hints. So, and for the web platform, this is probably going to be a Chromium only feature. We want to keep it very generic so other browsers can adopt it later if they want to. And they have already sort of given us feedback about how like formulating the comment, and we have modified it based on the feedback. It should be always allowed to ignore compile hint. So it's only a hint and it's not user visible whether a function got eager compiled or not. And also removing this is very forwards compatible because at some point the browsers can stop following the hint, and then web developers no longer have the incentive to add it, so they will stop using it. So nothing will go like too badly wrong if it has to be removed at some point. Some people have also brought up risks with this. So one is that web developers might overuse the magic comment, just put it everywhere, and this might force the browsers to start ignoring it. This is a bit of a philosophical question. Should we let web developers like shoot themselves in the foot with this comment or not? I guess you can have opinions both ways. There might not be an optimal set of compile hints for all browsers. I think this is a bit theoretical because ideally it should be basically the same functions exercised on a page load. Like, okay, maybe if there is some browser dependent code, then compile hints related to that should not, you might add them or not add them. But like most of the bulk of the code I expect to be browser independent, especially in the first version, we only have the very easy decision, was this function called or not? So it's not about like even call frequencies or anything like that. And these risks also apply to this Piffy hack. People have overused it. Browsers have not stopped following it. But it is easier to add this one function, one magic comment than Piffy all your functions though. So there is that. So, and why WebPerf working group? So why am I here and not in TC39? So this feature doesn't have really interoperability concerns because these are only hints. So if other browsers don't want to implement this, they don't need to, and nothing will go too badly wrong. Other browsers are in the current form not interested in implementing it, as far as we know. And the TC39 standardization process, it's a very heavyweight process and a consensus process. It's very good at sorting out interoperability on JavaScript, where we really need like commitment from all browsers before one browser is going to ship a feature. This is like the working model with TC39, but it's very heavyweight for this use case where the interoperability risk is very minimal. So that's all I have. Looking forward to the discussion if you have comments. Other than that, here's my email address. There are links to the explainer, which has an issue tracker if you want to file an issue, and there is a draft spec